Hello and welcome to the virtual 2020 Mackay Whitsunday Regional Integrated Science Forum. This is in COVID-19 style. This event is facilitated by Reef catchments through funding from the Queensland Government and the Australian Government under the original scope of the Regional Integrated Science Forum. The objective is to deliver current and relevant information about the Paddock to Reef and Reef Water Quality Improvement Plan programs while communicating the OGBR science and relevant Reef report cards. Just a quick introduction for myself. My name's Ingrid. I'm the Paddock to Reef coordinator at Reef Catchments. And for today's session, Kim Clyden, she's going to be our veteran host and facilitator for this second session. So please take it away, Kim.
Thanks, Ingrid, and hi everyone. It's great to have you joining us virtually. Firstly, to kick off today's session, we'd like to share a message from the Regional Traditional Owner Reference Group.
My name's Samala Deshong. I'm a Coomera woman. My country is situated from Cape Palmerston to St Lawrence in the Mackay Whitsunday Isaac region. I've been an active member for the Reef Catchments Traditional Owner Reference Group since it was started in 2006. I'd like to acknowledge the traditional owners of the land we stand on in Mackay, the Yuwibara people. We'd like to pay our respects to our elders, past and present. The 7 tribal groups in the region are Yuwibara, Coomera, Burradabana, Widi, Gia, Naro and Juru. A lot of us are on the coast. We are saltwater people. The Great Barrier Reef is important to the region's traditional owners. It's food source. We've got the islands. We have stories way back that are brought down to us. A ceremony, a performed men's business. So there's a lot of reasons why, we look after the reef. A lot of the catchments are nurseries, the seagrass beds are nurseries for, some of the fish, shrimp and that come from the reef. It's important to look after land and sea country. We've been brought up to look after country. That's why it's very significant to the traditional owners looking after land and water. We need water to regenerate. If it didn't, Mother Earth would die. So it's important for us to share our knowledge and work with Western science to help look after country for future generations.
Thank you, Samala. Today's 1-hour session features Dr. Ryan Turner, who will provide an overview generally of the water quality monitoring from the perspective of the Great Barrier Reef Catchment Loads Monitoring Program, with a focus on dissolved inorganic nitrogen, pesticide mixtures and imidacloprid. Following our second presenter, Ken Rode, will link the overview from Dr. Ryan Turner to the most recent work undertaken with imidacloprid and millmud under the Paddock to Reef cane runoff monitoring trial in the Mackay area. Dr. Ryan Turner is the Principal Scientist in Water Quality and Investigations with the Science and Technology Division of the Department of Environment and Science. He's served the Queensland Government since 2006 after work in the private sector. A quick Google of his name will reveal that he's been profiled in several podcasts of great interest, where he outlines his passion for water quality and relevance to life, industry, agriculture, and securing our future. Ryan knows the importance of gathering the actual data through monitoring, which is presented to catchment stakeholders and underpins the source catchment modelling used in the Paddock to Reef program and regional report cards, like those presented during our previous virtual event. The data has also been used by the UN in OECD reports, by the Bureau of Meteorology and eReef. Since 2009, Ryan has witnessed a massive change in how this information is received, particularly by growers and their willingness to be part of the solution. Welcome, Dr. Ryan Turner.
Well, thank you, Kim, for that lovely introduction. So I'm just going to give you a bit of an overview of the Great Barrier Reef Catchment Loads Monitoring Program in relation to the Mackay Whitsundays region. But this program is not possible without the team behind it, which is on the screen there, and also all our collaborators, especially in the Mackay Whitsundays region, but also across Queensland. So just getting into the start of the presentation, most of you would know about Paddock to Reef, so I won't talk about it today, but I'll just remind you that we sit in the middle there. We do catchment monitoring. We're looking at the water quality in the rivers, streams and creeks that export to the Great Barrier Reef. We assess sediments, nutrients and pesticides. We turn the sediments and nutrients into loads or total amounts. And the pesticides we convert into a risk metric, which goes to the Reef report card. One of our main objectives is to provide this data to the modelling team, which assess progress towards targets under the Reef WQIP, Reef Water Quality Protection Plan. And the other aspect of our program is to provide data to the marine monitoring, who assess condition every year. And our data that we collect is also a form of condition reporting. And that's a great segue to actually all the regional report cards that have slowly come online, which provide great insight into local regions, especially in Mackay Sundays. And our data also goes to those regional report cards. But none of this program is possible without our collaborators. The collaborators are the backbone of this program. We've got over 60 individual groups, organisations and individuals helping us take samples, and a special thanks and appreciation goes out to Reef Catchments and Catchment Solutions from the Mackay Sundays region, who help us achieve what we do in this program and the water quality sampling. It's not pretty work sometimes when you're out there in an East Coast low and it's torrential rain and you've got to collect a bottle or you're emptying an auto sampler. So it's a massive thanks to those guys. So where do we monitor? We're from the tip of Queensland down to the Burnett Mary. We also have a sister program in Southeast Queensland and everywhere in between. And we've got a number of sites in Mackay Sundays, which I'll discuss a little bit later on. We're in 20 of the 35 basins. We monitor it currently at 69 sites across Queensland, and we're capturing the majority of constituents that go out to the Reef Lagoon. How do we do it? Well, we're looking at diffuse contaminants. So we're not pointing the finger at anybody. We're assessing a point in a river or a waterway, and we're saying that everybody above there, no matter who you are, what you do, you have a footprint and you're contributing to that water quality. We look at it in event conditions. That's when the rivers are flowing due to runoff or rainfall or storms or cyclones. And we also assess the condition or the water quality in dry conditions. So we call them ambient conditions. We do this on a how long is a piece of string kind of time frame. It could be hourly, it could be weekly, or it could be monthly. We use some smart tools to do our assessments, auto samplers, in situ probes, but we still do traditional grab samples with a bottle and a pole. And all that data goes back via a lab, and then we report on it. So this is what it looks like. This is a double wall cyclone proof shed. It's off the grid, it's self-sufficient. We put some infrastructure into the waterway, pumps, certain types of probes and assessment tools, and measuring tools. One of them is this little device here on your screen, which is called an acoustic Doppler current profiler. It measures the velocity of water. It also can measure the backscatter of sediment. And we've actually got a project with Advanced Queensland and QUT to start to look at real-time sediment loads coming out of that site. We're also heavily moving into this real-time world. We know our stakeholders and constituents and industry bodies are wanting this data in a more timely manner. So the traditional lab-based sampling with discrete samples aren't necessarily always meeting the brief. So we're starting to investigate using real-time probes to get real-time data and feed that back to whoever is actually interested in water quality, whether it be for extension or research or just using it as tools to educate. And we're also using this little baby here called a Trios Opus. It measures nitrate in real time. We've had some great success, and we're about to roll out 40 more of these across the state, which is really cool. But yes, the backbone is still our discrete grab samples, taking samples, putting them into these fancy little fridges called avalanche ISCOs, and then we send them to the laboratory. But the most important thing behind this program, not only are our collaborators, but our quality management framework. So we have quite strict quality assurance and quality control procedures. And we champion this kind of high quality monitoring across the state. And we offer our procedures and our methods to anybody who's interested in water quality monitoring. And we also come up and train you for free. All we ask is that you pay for our accommodation and flights, and you can have our procedures, and we give you a one-day training because we're quite passionate about making sure whatever water quality is sampled within the state can be used by multiple groups, multiple agencies. Unfortunately, we're currently meant to be in review, but review has been delayed due to current situations. And we actually plan to have that international review of the program hopefully early May. So let's get into some data. Now, before I get into the data, I just want to highlight, I'm really going to be just touching on the surface, a bit of a highlights tour. And that if you ever want anyone from my team, myself, to come and join a shed meeting to delve into a bit of data more, we're more than willing to. So one thing to note, in the Mackay Whitsundays region, we've been going now for up to 14 years at some of our sites for monitoring. It's now probably one of the most data-rich regions from a water quality perspective. And with that data richness, we're actually gaining great understanding and knowledge of the water quality aspects and what's happening in this region. There's over 3,500 samples now collected in the different waterways in the Mackay Whitsundays region. They're discrete individual samples. And I would actually argue it's probably one of the most dense data sets now in the country. But also what has spun off on this is a lot of local extension and engagement. And there's now probably over 1,000 water quality samples been taken by extension officers, farmers, landholders, and that's value adding to the water quality data set and enabling us to get greater insight into the water quality situation for this region. So soon to be released, we now produce this thing called the story map. It's done through an Esri product. And we're hoping to release this very soon with the Reef report card. And what the cool thing about this story map kind of concept for the delivery of our data is that you can go on your own journey to discover where and what water quality aspects you want to investigate. It's very interactive, but one of the coolest thing is our data is now freely there, available for download when you want it, all available via the web. And as soon as this is released, I will definitely share the URL link. So just a high level whirlwind tour of what's going to be coming out of that story map. So in the 2018-19 year, from a climate perspective, it followed quite a dry condition. We call that an antecedent condition. And generally what happens with that is the catchments are a little bit more charged, have a bit more, they haven't gone through an exhaustion period. Also, there's less ground cover and those kind of things. So often what you find is you get slightly elevated loads in the subsequent year. So the 18-19 year, we were expecting slightly elevated loads compared to normal. So that's kind of your total amount of a constituent compared to the flow that is delivering that. Also in the 18-19 year, we saw some very unusual storm events in the December period. And that probably coincided with that high risk period where there was application of fertilizers and pesticides. So there was that more chance of delivery to our waterways. And then also there was quite a bit of weather event in the late January, early February period, which delivered a lot of the load as well. So just some high level highlights from that story map. The Proserpine River had quite high level dissolved inorganic nitrogen loads going out to the marine ecosystem, and most likely due to those climatic conditions, and also that risk period where we received those early December rains when maybe some application was occurring. And that sort of high level dissolved inorganic nitrogen load is repeated in nearly all of the systems. Down to the O'Connell, yet again, that dissolved inorganic nitrogen and some dissolved organic phosphorus was elevated more so than normal. And when we moved down to the Pioneer, the same story. The dissolved organic nitrogen was above trend to what we normally see. And we would love to engage with the regional people that have the local knowledge just to understand that more. Is it maybe due to that high risk window of when application of certain things were done in land management, or is it groundwater, or is it due to that antecedent condition? So we really need to delve in that, and we can only do that with local knowledge. Sandy Creek in the Plain Basin, just further south, they were pretty much on average or a bit lower than normal, and they actually didn't receive that east coast, the trough and the monsoon trough down as far as the Plain Basin, so the loads were a bit lower. And just on an average sense, just focusing on dissolved inorganic nitrogen here, here's the basin, the waterways that we monitor. In the bar graph, in that orange graph on your screen, is the annual average load, so the total amount going out into the waterway. And the green circle is basically that load divided by the catchment area. So the green circle I'll get you to focus on, although Pioneer in that orange bar is the largest load, the green circles are sort of explaining what is being delivered per square kilometre area. And you can see that, yes, Pioneer is the largest load, and its area, that green circle, is around like that, let's call it above 200, 250. But the Proserpine and Sandy Creek also deliver that similar kind of ratio of load. So those three focus areas is where we can try and improve some management practice on ground and try and bring those numbers down. So I'm going to move on to pesticides and how we manage water quality from a toxicant point of view. I just wanted to highlight Anzac arm cans is no longer, and now we have this website called waterquality.gov.au. So please go there if you want to look at any guidelines. That's your point of truth from now on. And talking about guidelines, most of you on this forum right now would know about guidelines. Anything that's detected below a guideline or threshold is low risk. Anything detected above is high risk. And what I want to show you is a little product that we're about to release. We've just got to go through some departmental consultation and then some public consultation. But there's going to be called the Pesticide Exceedance Dashboard, yet again delivered through the web. Basically, you can click on a circle here, and this is like real data that you're seeing right now, and it will pop up. And let's say you're investigating Sandy Creek at Homebush. You can see all the historical data when exceedances occurred. That's the dots on the screen there. They're also color coded depending on what exceedance, whether it's an irrigation guideline or an ecosystem guideline, or if it didn't exceed, those black dots. But it's also got the hydrograph there, that blue line, so you can see what's happening. The cool thing is you can also zoom in and you can start to investigate. And we're hoping that people will be able to use this to help with extension, help with education, and also just get a greater understanding of water quality. And this data will come into this platform as soon as the laboratory releases it, so you don't have to wait for me and my dulcet tones to come up and talk to you guys. One thing I want to take you through a journey now is just how we assess multiple chemicals. So we look at 22 chemicals in the Reef plan, and basically through some smart mathematics, we sum them together and we get one score. So instead of looking at Diuron, Imidacloprid, and Imazepyk and those things, we can look at it in one aspect. Why these 22 chemicals? Well, these are the ones we detect the most frequently, and some have the highest amount of toxicity. So for a waterway where we sample, what we're trying to aim for is this low risk category. And we want to be below that 5% of species effect. So here's the data for the last 3 years from your region. We've got O'Connell on the left and all the way down to the south and Sandy Creek and Homebush. And you can see that O'Connell and the Plain Creek and the Plain Basin, they're in that kind of lower risk category. But the Pioneer, Proserpine, and Sandy Creek, they're definitely up in the high risk category. And this is the kind of area where we need to improve our management practice adoption, improve our footprint, and try and wind back or try and manage those chemicals in a better way. But let's look at those three little basins and just see what is contributing to that high kind of effect of species. So when we look at the Pioneer, and the next three graphs are very similar, they're just pie charts basically of the chemicals or the pesticides that are contributing most to those high scores. So in the Pioneer, it's dominated by atrazine, imidacloprid, and Diuron. It equates to about 80% of that score risk. In the Proserpine, we still see the same pattern, yet again around about 80% from atrazine, imidacloprid, and Diuron. And then down in Sandy Creek, we see a similar story. So I just want to investigate this a bit further, looking at imidacloprid and Diuron. So imidacloprid, the guideline or the draft guideline in Queensland is 0.11. And we know imidacloprid is really soluble. When it gets into the water, it moves and it gets very quickly into our waterways. So here's the hydrograph, so the blue line in flow, and the dots on the screen are your concentration points. And we've seen for quite a long period now, lots of exceedances, quite high exceedances. There is some, if we zoom in here a little bit into Sandy Creek and these concentrations of imidacloprid, there is some good news potentially coming out. And we've seen maybe a plateauing, well, we've probably definitely seen the plateauing and maybe a downward trend. So that's really good credit if this is true in the next couple of years to the positive management action that's been done on the field and on the ground. We do know this is possible because in the Tully catchment up in wet tropics, we are seeing those reductions occurring. So that's really good. And for my last slide, I just want to talk about Diuron. Yet again at Sandy Creek Homebush, the dots represent concentration. The blue dots are Diuron. And what we have seen over the last few years is a trend downwards in detection of Diuron, and we're assuming that's probably due to better management practice and also less use. But we are seeing an increasing trend in Imidacloprid, which is probably a switch of Velpar to Bobcat or Maxi. The jury's out on whether that's a better ecological response, but there is some good news there. So for further information, please Google Reef Plan and you'll find out a bit about us and everything about Reef Plan. And there's that quite obscure link there as well to our last year's story map, and I'll definitely be sending around the story map for this coming year. And thank you, everybody.
Well done. Where's the applause? You know, that's what I'm missing. Thank you very much. I know everyone's clapping. Our next guest today, of course, we mentioned earlier, is Ken Rode, Senior Scientist with the Department of Natural Resources, Mines and Energy in Mackay. Ken is a water quality scientist who has designed and implemented successful water science projects in central Queensland for over 25 years. He said that shows his age. Held in high regard for his specialisation in regional scale water quality impacts, I should say, modelling and monitoring of natural resource management activities. Today, he's going to share the data details of the Mackay cane paddock monitoring of Imidacloprid, such a good word, and millmud to manage risks of freshwater ecosystems. Take it away, Ken.
Thanks to all the people online. As Kim mentioned, I'll talk about our paddock monitoring project in the Mackay Whitsunday region, focusing on Imidacloprid and millmud. Before I do that, I'll just touch on our multi-farm sub-catchment data, just to focus on Imidacloprid, so take a step up from the catchment scale that Ryan talked about to the sub-catchment scale. And then I'll go through some of the latest paddock monitoring, particularly around Imidacloprid and runoff, and sort of where to next. So I suppose the question is, why focus on Imidacloprid and millmud? I think that now forms part of the water quality risk framework. Therefore, the paddock modelers in the Paddock Reef program need to be able to model these. And to do that, they obviously need data. So at the moment, I think they're modelling millmud as a manure. So if we can provide some actual millmud data, that'll improve the paddock models. So multi-farm catchment within the Sandy Creek catchment that Ryan mentioned. So starts off at Moroney, flows down towards North Eaton. It's about a 3,000 hectare catchment, which is 9% of the Homebush gauging station catchment area. I think more importantly, it includes 19% of the cane in that Homebush area. So it's a pretty good representation of, I think, what happens in the Homebush catchment. Focused on Imidacloprid. So the vertical blue bars, similar to what Ryan showed earlier, our discharge for each event. The brown filled in symbols are Imidacloprid, what we call an event mean concentration, so the mean for each event. The black crosses are the annual means. Ryan mentioned about a 0.11 microgram per litre proposed guideline values. That's the red dotted line across towards the bottom here. So we can see the first few years of monitoring from 2019 to 2012, everything was below that proposed guideline value. Since then, they've slowly started increasing. If we look at annual load, so the kilograms of product of active ingredient that we've lost over the years, also slowly increasing. 2018-19 was an interesting one. Approximately 22 kilograms of product with a relatively high annual concentration here. So if we see these three brown dots that are about 1.1 micrograms per litre, those three events there produced about 60% of the runoff for the season. So we got majority of the season in runoff, particularly high concentrations. That's what gave us the high load for the year, and then after that it sort of slowly dropped off through the season. If we move on to our actual paddock site, just to locate ourselves, this is Marion Township across to the northwest here, Mount Vince, northwest. Mount Vince just at the top right of the photo here. So we had a 3 hectare cane block that was split into various treatments on a black vertisol or a cracking clay. Slope of about 1%, road length 220 metres. So each of our monitoring sites down here, we did start the trial with 2, we increased to 4, we're now up to 5. So if we zoom into one of those monitoring sites, similar equipment to what Ryan mentioned, but at a smaller scale. We've collect runoff from 4 rows in each treatment, direct it through a runoff flume where we measure water height. That's logged in a data logger. ISCO overland sampler that Ryan mentioned collects the water samples from the flumes, refrigerates them until we collect them for lab analysis. We also measure rainfall amount and intensity, also off the grid with batteries and solar panels. This trial has been going since 2009. We've monitored a raft of different things over the years to do with nitrogen rates, different herbicides, different row spacings. We added 2 treatments in 2012, mainly to look at banded herbicides. That went into a fallow looking at plus or minus legumes, plus or minus trash. Tried to even things up there with plant cane with different rates of nitrogen. Then we get into first return of the current cane cycle, looked at nitrogen rates and enhanced efficiency fertilisers. We also started applying imidacloprid. And then 2018, we've started looking at mill mud. So what I want to focus today on was just the imidacloprid results and our mill mud results. So we start off with imidacloprid, as Ryan's mentioned, active ingredient of Confidor, used to control various cane grub varieties, applied subsurface as a still split application. Applied at 1.3 litres per hectare of product. So we've applied it to 2 treatments in 2006 and a different 2 treatments in November 2018. There's actually no imidacloprid treatments, so there's just 2 treatments the same rate. In 2016, a different 2 treatments in 2018. Should just point out here that cane grubs aren't an issue at this site, so we've applied imidacloprid because it is part of our normal pesticide suite, so we can get analysed for no extra cost, and because imidacloprid data was required for the catchment paddock modelers, thought it was a good opportunity to look at it. So if we look at these blue bars, 2016-17 data in the year of application, at 1,000 millimetres of runoff, so that was dominated late in the season by Cyclone Debbie. First runoff was about 90 days after application. That's probably average for the 10 years that we've been doing this sort of work. And we got to lost that initial season about 1% of applied product. So we lost 4.5 grams per hectare. We applied 450 grams. So loss is about 1%, which equates to the better end of the scale for a lot of the herbicide work we've done. So if we look at the second season, these sort of orangey bars, a lot less runoff that year, 400 millimetres, and we're getting about 0.1, 0.2% loss still in that second year. If we look at 2018-19 for our second application, these other two treatments, our loss rates are a lot higher. About 550 millimetres of runoff, which is probably about average for this site over 10 years. Our first runoff was 20 days after application, so compared to 90 in that first event. So getting our losses a lot closer to application. So that equates to loss for the season of about 4 to 8%. I'm not sure why we got such a big variation between treatments, but and then if we look at the grey bars here in our third year of application for these two treatments here, we're still getting 0.15% loss. So consistent losses after that second year of application. So if we move on to actually look at concentrations, so this is a log scale. You just remember that, our 0.11%, 0.11 microgram guideline value sits through here somewhere. So we get our degradation through the season with exhaustion and whatnot. The important thing to note, I think, here with the imidacloprid particularly is there doesn't seem to be a lot of dissipation or degradation from the end of one wet season to the start of the next. So if we just look at these orange dots, for example, just pick a treatment. At the end of one runoff season is about what they are at the start of the next runoff season. There didn't seem to be a lot of degradation through the season, so whether that's because it's subsurface applied, the product moves down the profile through the wet season, with these decrease here, through the dry season, whether it's coming back up through evaporation and so forth. It's not sure on what's happening there. I think that's why it's hanging around. There doesn't seem to be much degradation through the dry season. If we compare those concentrations to something like Diuron, we do get more of a degradation, I think, through consecutive years, although we get some high concentrations in second year after application. In that second year, the concentrations do seem to be dropping. So summary there, runoff losses, 1 to 8% of application. In that season of application, concentrations are similar to applied surface applied herbicides. As I said, still detected in that third season after application. But I should point out that these results may not be typical for other soil types where cane grubs might be an issue, where there's maybe free draining soils. I guess the message here is only apply it where and when it's required. We move on to our millmud data. What we tried to do here is get data on millmud as compared to more typical products. So our product of choice here was a liquid product, so liquid one shot. And what happens if we add millmud on top of a normal fertilizer product. So 130 kilos of nitrogen is our 6 easy steps rate. So if you look at a liquid only, was all our N coming from liquid. We had a millmud only treatment where we looked at trying to supply all the N from millmud. What happens if we incorporate millmud in that 130 N, so apply what was deemed a typical millmud application and top it up with liquid? Or what happens if we ignore the 6 easy steps and put our millmud rate on top of that rate? Our nil N treatment was basically just to look at N mineralisation of the soil. So that was what we're trying to do with our millmud treatment. So it's applied as a band, multiple passes required to get at 50 or 80 tonnes per hectare. You can see the brown stripe in the bottom right corner of the photo here was our liquid product applied just before the millmud. If you look at nitrogen runoff, so first season of data, there's not a huge amount of difference in our nitrogen runoff loads for this season. Obviously, where we applied more nitrogen with our mill mud on top of a 60 steps rate, our rates are somewhat higher. They're 130 nitrogen rates. Runoff rates, loads aren't all that high, even from a nil nitrogen rate, which I thought was interesting. Different story for phosphorus, given that mill mud's loaded with phosphorus. So applied 20 kilos of N, even for the nil N treatment here. So these two treatments on the right-hand side are about 20 kilos of phosphorus applied, whereas anything to do with mill mud was 80 to 140, 150 kilograms, I think, of phosphorus is actually applied. So our runoff rates of phosphorus started increasing substantially, particularly where we're mill mud only. Cane yield, very little difference across where we had 130 kilograms of liquid. Mill mud didn't seem to do too much to yield, slightly less where we had mill mud only, slightly less again where we had nil nitrogen. So summary there, N runoff from mill mud's not substantially higher than the equivalent liquid rate of nitrogen. 6 easy steps, N rate plus the mill mud obviously gave us the highest N runoff because of the higher total N applied. Phosphorus runoff from mill mud was substantially higher than other products just due to the higher P application. Release of nitrogen from mill mud doesn't appear to match crop requirements, but I guess the proviso there is people don't apply mill mud as their only source of nitrogen. It's generally applied as a soil ameliorant. Where to from here? So this is our final routine for the current crop cycle. We'll be heading into a fallow at the end of 2020 after this current crop is harvested. So we need to design some fallow treatments. I've just put some questions up here. Don't expect people to answer here and now, but maybe some of the things we're looking at, and if somebody's got some ideas, whether we look at plus or minus a current trash blanket, plus or minus a legume, continue with our mill mud story, whether we go incorporated versus not incorporated, whether there's other things that people, the industry, would think there's a need for, will let us know. Yep, thank you. So yeah, thanks to our amazing collaborator and to the Queensland Government and the Australian Government for funding this work. Thank you.
So, in summary today, I'd like to take this opportunity firstly to thank our presenters, Dr. Ryan Turner and Ken Road, and congratulate them on their first virtual Mackay Whitsunday Regional Integrated Science Forum. Any further questions should be directed to the speakers via RCL staff who've organised this event. Publishing of any information disclosed during this event will require the permission of RCL, who are the organisers, and the individual government media approvals via departments from our speakers. Ryan today helped us understand how the data from monitoring is gathered and which tools are used to measure various elements like phosphorus, other chemicals and nutrients. Explain the knowledge sharing available through training programs to ensure monitoring efficacy, which is something I'm sure many of you will be following up. Now, Mackay has been monitored for the past 14 years with 3,500 samples collected. I found that astounding, making it one of the most dense data sets available in the country. Well done. Story mapping. This was great. The story map was of great interest to you as well, assisting stakeholders, service providers and communities to understand their catchments and its inclusion, he spoke of, in the upcoming reporting. So we really look forward to that. Breakdown of current Proserpine River, O'Connell River and Sandy Creek loads, which was really interesting as well, and the impacts of antecedent climate conditions combined with high rainfall events. He presented the dissolved inorganic nitrogen graphs, pesticide concentrations, and provided access to waterquality.gov.au, which is the new website you should check out post this event. And also discussed the pesticide exceedance dashboard coming soon to a screen near you. Ken provided real insight into the runoff data required through monitoring to assist modelling, which now forms part of the water quality risk framework, explained proposed aquatic ecosystem protection guideline values for imidacloprid for the protection of freshwater ecosystems. He also discussed the engagement of growers in the Mackay region, which is really good to see, with an overview of trials from 2009 to 2018 and a more detailed presentation of imidacloprid rate applications and losses from 2016 to 2019. He also presented that comparative runoff of nitrogen in mill mud versus liquid and phosphorus before previewing the next steps. So in conclusion, that is definitely what we have covered off on today. Thank you very much for joining us. I'll now hand you back to Ingrid, who has the final words.
Thanks all for joining in this session today. I want to thank the presenters for today's session, really informing us on those aspects that we want to hear as part of Paddock to Reef. Thanks for Kim for excellent facilitation. Thanks to the working group help planning in these sessions, and thanks to Samala from Torg for her really good acknowledgement of country video. So once again, thank you, and I hope to see you at one of the next sessions. And that concludes session 2 of our virtual integrated science forum.